2, 3, funky.
Hey guys, welcome back to my channel, and in today's video I'm going to go over horizontal and vertical trajectory when it's launched from an angle, I believe. And I hope you guys are having a good day or had a good day, and without any more talking, let's just get started. So basically, since we're going over like a lot of the same thing, I'm just going to read the question one time because it's going to be the same question, different points on the parabola or like the trajectory. So here it goes. A ball is launched upward at an angle. The diagram shows its location in 1 second intervals. I read so fast. Rank the 3 indicated locations based on horizontal speed v of x and vertical speed v of y. So we know that for horizontal speed is always going to be constant, so they're all going to be the same. That's just how it is because gravity does not happen to affect the horizontal side of the trajectory, so it's always going to be the same from the initial to the final. It's going to be the same. For v or y, however, as it goes up towards the peak, which in this case is E, it is going to decrease the speed because it's working against gravity, and so gravity is going to be trying to pull it down as it goes up, so it's going to decrease. And as it falls down, it's going to increase in speed because gravity is going to be pulling on it and making it fall even faster, so it's going to increase speed as it goes down. So in this case, ACD, A would be the greatest because as it goes up it increases, the middle would be C, and the largest would be D. Okay, so unlike in the other one where it was B, C, it was the B, D, and E or something, I don't remember, but in this case we have B, E, and F. And so like I said, horizontal is always going to be constant. Even at the peak is going to be the same number that it started with till the end, so that's always going to be the same. For vertical, however, we have B and F. Like I said, as it approaches towards the peak is going to decrease, and as it falls away from the peak is going to increase. And we know that the peak is always going to be 0 for vertical because at that moment in time it's not moving, nothing's affecting it, so it's going to be 0. So that's going to be the smallest. For B is going to be the greatest because because it's on the left side, and because as you throw it up the speed is a lot, but as it falls down it's going to be negative now, and so that's going to be smaller than when you're throwing it up. Okay, so now we have a really easy one because they're literally right back to back and on the same side where it's falling and gravity is pulling on it because it's going in the same direction with gravity. Horizontal always going to be the same, not even going to go over it. We have F, G, H, and it's falling down, like I said, it's going to be increasing. So the greatest is going to be starting from the bottom because that's where the greatest speed is. So working your way upwards, your greatest is going to be H, your middle is going to be G, and your least is going to be F because like I said it increases. So obviously the greatest speed is on the bottom, and then work up and you got it. Alrighty, so basically this is the same exact thing we have been doing, but now we have to put into words. And so horizontal, I keep mixing those up. Horizontal is going to be the same throughout, and so it's going to be constant and it's never going to change. For vertical, however, it's falling down, so it's going in the same direction gravity is, and gravity is pulling on it and it's accelerating more and more as it reaches towards the ground. And so basically it's going to increase the whole time. If it's from F to I, it's going to increase the whole time. Okay, so same question, but this time we have to go from E to H. We know that E is the peak because it's at the very top and it's going to be 0. So we have to figure out how it's going to change from E to H. And again, like I said, it's going to increase as it goes down. So yeah, that's it. It's just going to increase the entire time from 0 to whatever acceleration is probably going to be like negative 29.6. I don't know, but yeah. Okay, so going from B to E, you are throwing it up and gravity is going to try and pull on it, and it's going to decrease as it goes up and up, and so it's going to decrease the entire time. I feel like the only time where you would actually have where it first decreases then increases would be if you went from like point B to H. So if you crossed across the peak to the other side from where it's decreasing to where it actually accelerates, then yeah. It's crazy because I didn't even realize I had a problem like this. I was talking about in my last one. But in this case, for vertical from D to H, you're going from the side where it is decreasing. So when you throw it up, decreases, to the side where it accelerates when it falls towards the ground. So obviously it's going to first decrease because D is on the decreasing side and H is on the accelerating side. So yeah, just like I said in the last one, that's your answer.